So I was asked the question about the intermediate value theorem. So I want to make a video about the intermediate value theorem. So the intermediate value theorem is one of our polynomial theorems, and I'm going to make several videos on polynomial theorems. And they're really, really useful when you got an x squared, x cubed, x to the fourth, x to the fifth, x to the sixth. They tend to be used with higher order polynomials. So in this case, I got x cubed plus 5x squared minus 4. And they ask, is a real zero between x equals 2 and x equals 1? Now, I'm going to explain the intermediate value theorem, and then I'm going to show you how to use it. So the way the intermediate value theorem works is it's based on the graph of the function. Okay? And so we're going to just take some random, here's some function, and it goes something like this, right? Here's some function, okay? And a 0 is when y equals 0. And y equals 0 on the x-axis. So what that really means is when I ask you, is there a 0, what I'm really looking for is x-intercept, okay? X-intercept. So the way the intermediate value theorem works, guys, is we're going to pick a point over here, and the function's positive. And we're going to pick a point somewhere over here, and the function is negative. If the function goes from negative to positive, the only way it can do that is to hit the x-axis. So if I try this guy and get a negative result, and I try this guy and get a positive result, we know there's a 0 between them. If I try this guy and get a positive result, and I try this guy and get a negative result, we know there's a 0 between them. Fair enough? One more scenario. If they're both negative or they're both positive, what does that mean? There's not a 0 between them. If they're both positive, there's not a 0 between them. So you have to have one negative and one positive, then you know there's a 0 between them. That is the intermediate value theorem. It sounds way more complicated in math books. That's all it is. So how do we check this? Well, there's two ways. I'm going to show you my favorite way, which is synthetic division. Synthetic division. Okay? And synthetic division uses the coefficients of the polynomial. Okay? So I'm going to set this up for synthetic division, and I'm actually going to do it twice. Why? Because I have to try both zeros. Now, you always divide by the zeros. So in this case, I'm dividing by 1 and 2. Okay? And then you list your coefficients from lowest to highest. So I'm going to go 1, 5, 0, minus 4. Because I've got x cubed, x squared, x to the first, that's the 0, and then a constant. Okay? Down here, I'm going to put the exact same numbers, 1, 5, 0, and negative 4. Now, I'm going to show you the other method, but I like this method because if you don't have a calculator handy, the math is easier. Okay? So if you do have a calculator handy, then they both work. So here goes. Synthetic division, all we do is copy the first one, and then multiply. 1 times 1 is 1, and then add. 5 and 1 makes 6. 1 times 6, 6. 0 plus 6, 6. 1 times 6, 6. Negative 4 plus 6, 2. Don't actually care what the number is. All you really care about is the first 0 was positive. Okay, now come here and do the same work. Here goes. Okay, copy the first one. 2 times 1, 2. 5 plus 2, 7. 2 times 7 is 14. 0 plus 14 is 14. 2 times 14 is 28. And when you add these, you're going to get 24, which is also what? Positive. What does this mean to me? No 0 exists between x equals 1 and x equals 2. Okay? That's what that means to me. Pretty simple. Now, told you I'd show you another way. throwing stuff on my desk here. Told you I'd show you another way, okay? The second thing you need to know is the remainder theorem, okay? So the remainder theorem, let me bring that up real quick. The remainder theorem says, well, I'm not going to tell you what it says in a book because it's confusing. But here's what it means, okay? The remainder theorem says if you do synthetic division or long division, that the remainder is equal to f of k, where this number here is k, okay? So let me say that in plain English. F of k would be f of 1. F of 1 would be if I plugged 1 in for x in this equation. And I'm saying that if I put a 1 here, I put a 1 here, and I do the math, the answer will be 2. If I put a 2 here and here, the answer will be 24. So let's try it, okay? So I'm going to say x cubed plus 5x squared minus 4. Okay, well, 1 cubed is 1. 1 squared is 1 times 5 is 5. And if I say 1 plus 5, I get 6. 6 minus 4 is, ta-da, 2. Okay, let's try this other one. I'm going to say x cubed plus 5x squared minus 4. All right, well, 2 cubed is 2 times 2 times 2, which is 8. 2 squared is 4. 5 times 4 is 20. And 8 plus 20 is 28. 28 minus 4 is 24. Ta-da! So, synthetic division is one way to see if these are both positive, both negative, or opposite in sign. You can also plug the numbers in to the function, and you get the same answer. So, how can you use this as a shortcut? Okay, how can you use this as a shortcut? Well, let's say I give you x to the 5th plus 4x to the 4th plus x to the 3rd. Okay? And I told you to find f of 7. And you didn't have a calculator. Now, if you have a calculator, you can type 7 to the 5th and 7 to the 4th, and it's pretty simple. But if you had to find 7 to the 5th by hand, and you had to find 7 to the 4th by hand, you would be a little angry. Well, f of 7 is equal to synthetic division by the number 7. So this will be a 1, this will be a 4, this will be a 1. So you got 5th, 4th, 3rd, 2nd, 1st, and a constant. So you have to have those zeros, or this doesn't work. Copy the 1. 7 times 1 is 7. 4 plus 7 is 11. 7 times 11, 77, right? 1 plus 7 is 78. Now here's where it gets tricky. Okay, I want to find 7 times 78. Yeah, okay, that's kind of tricky. Would you rather do 7 times 78, or would you rather do 7 to the 5th? Now, if you say you'd rather do 7 to the 5th, don't do this, okay? But if I don't have a calculator, how would I do that? Well, I'd actually come out to the side and I would multiply it out, right? So 7 times 8 is 56. 7 times 7 is 49. And then you'll add 5. So that's going to give me 54, right? So 54. So 546. So that'll be 546. Whoops, wrong place. 546. This is why you shouldn't do your math in pen. What's 546 plus 0? It's going to be 546. I guess I could have left it. Okay, then you got to do 7 times 5. Okay, well, that's not much easier than just multiplying 7 to the 5th. But what I want you to know is if you plug in 7 or you do this, they both work. Now, at some point I do get lazy. I happen to have a calculator. So I'm going to type 7 times 546. 7 times 546. And I get 3822. So 3822. Okay? Add 0 to that, you get 3822. 3822 times 7, I get 26,000. Ooh, that's a miss. 26,754. 754. Okay, that is my remainder. Cool. Okay, supposedly that's f of 7. 26,754. Unless I made a math boo-boo. Okay, now I'm going to take this equation and I'm going to plug in 7. So 7 to the 5th plus 4 times 7 to the 4th plus 7 cubed. Okay, and I'm going to type that. I'm literally going to put my calculator up here and show you that I'm going to type that. So I'm going to say 7 raised to the 5th power plus 4 times 7 to the 4th power, right? Plus 7 cubed. I'm going to press equal. 26,754. Pretty cool, huh? So anyway, the remainder theorem does work. Would you rather do this math or this math? That's up to you, but that's what the remainder theorem says. If your instructor insists, some instructors will insist you have to use synthetic division if I ask you this question, and you don't feel like you're really good at this, you can always check your answer by plugging the number in, okay? So I hope this helps someone. If you have any other questions, leave them in the comments, or if you want to see a different video, let me know, and I'll do my best to work it.